A web application or web app is any application software that runs in a web browser and is created in a browser-supported programming language and relies on a common web browser to render the application. Web applications are popular due to the ubiquity of web browsers, and the convenience of using a web browser as a client, sometimes called a thin client. The ability to update and maintain web applications without distributing and installing software on potentially thousands of client computers is a key reason for their popularity, as is the inherent support for cross-platform compatibility. Common web applications include webmail, online retail sales, online auctions, wikis and many other functions. History: in earlier computing models, for example in client-server, the load for the application was shared between code on the server and code installed on each client locally. In other words, an application had its own client program which served as its user interface and had to be separately installed on each user's personal computer. An upgrade to the server-side code of the application would typically also require an upgrade to the client-side code installed on each user workstation, adding to the support cost and decreasing productivity. In addition, both the client and server components of the application were usually tightly bound to a particular computer architecture and operating system, and porting them to others was often prohibitively expensive for all but the largest applications. In contrast, web applications use web documents written in a standard format such as HTML and JavaScript, which are supported by a variety of web browsers. Web applications can be considered as a specific variant of client-server software where the client software is downloaded to the client machine when visiting the relevant web page, using standard procedures such as HTTP. Client web software updates may happen each time the web page is visited. During the session, the web browser interprets and displays the pages, and acts as the universal client for any web application. In the early days of the web, each individual web page was delivered to the client as a static document, but the sequence of pages could still provide an interactive experience, as user input was returned through web form elements embedded in the page markup. However, every significant change to the web page required a round trip back to the server to refresh the entire page. In 1995, Netscape introduced a client-side scripting language called JavaScript, allowing programmers to add some dynamic elements to the user interface that ran on the client side. So instead of sending data to the server in order to generate an entire web page, the embedded scripts of the downloaded page can perform various tasks such as input validation or showing hiding parts of the page. In 1996, Macromedia introduced Flash, a vector animation player that could be added to browsers as a plugin to embed animations on the web pages. It allowed the use of a scripting language to program interactions on the client side with no need to communicate with the server. In 1999, the web application concept was introduced in the Java language in the Servlet specification version 2.2. 2.1. At that time both JavaScript and XML had already been developed, but Ajax had still not yet been coined and the XML HTTP request object had only been recently introduced on Internet Explorer 5 as an ActiveX object. In 2005, the term Ajax was coined, and applications like Gmail started to make their client sites more and more interactive. A web page script is able to contact the server for storing retrieving data without downloading an entire web page. In 2011, HTML5 was finalized, which provides graphic and multimedia capabilities without the need of client-side plugins. HTML5 also enriched the semantic content of documents. The APIs and document object model are no longer afterthoughts, but are fundamental parts of the HTML5 specification. WebGL API paved the way for advanced 3D graphics based on HTML5 Canvas and JavaScript language. These have significant importance in creating truly platform and browser-independent rich web applications. Interface: through Java, JavaScript, DHTML, Flash, Silverlight and other technologies, application-specific methods such as drawing on the screen, playing audio, and access to the keyboard and mouse are all possible. Many services have worked to combine all of these into a more familiar interface that adopts the appearance of an operating system. General-purpose techniques such as drag and drop are also supported by these technologies. Web developers often use client-side scripting to add functionality, especially to create an interactive experience that does not require page reloading. Recently, technologies have been developed to coordinate client-side scripting with server-side technologies such as PHP. Ajax, a web development technique using a combination of various technologies, is an example of technology which creates a more interactive experience. Structure: applications are usually broken into logical chunks called tiers, where every tier is assigned a role. Traditional applications consist only of one tier, which resides on the client machine, but web applications lend themselves to an n-tiered approach by nature. Though many variations are possible, the most common structure is the three-tiered application. In its most common form, the three tiers are called presentation, application and storage, in this order. A web browser is the first tier, an engine using some dynamic web content technology is the middle tier, and a database is the third tier. The web browser sends requests to the middle tier, which services them by making queries and updates against the database and generates a user interface. For more complex applications, a three-tier solution may fall short, and it may be beneficial to use an n-tiered approach, where the greatest benefit is breaking the business logic, which resides on the application tier, into a more fine-grained model. Another benefit may be adding an integration tier that separates the data tier from the rest of tiers by providing an easy-to-use interface to access the data. For example, the client data would be accessed by calling a list clients function instead of making an SQL query directly against the client table on the database. This allows the underlying database to be replaced without making any change to the other tiers. There are some who view a web application as a two-tier architecture. This can be a smart client that performs all the work and queries a dumb server, or a dumb client that relies on a smart server. The client would handle the presentation tier, the server would of the database, and the business logic would be on one of them or on both. While this increases the scalability of the applications and separates the display and the database, it still doesn't allow for true specialization of layers, so most applications will outgrow this model. Business use: an emerging strategy for application software companies is to provide web access to software previously distributed as local applications. Depending on the type of application, it may require the development of an entirely different browser-based interface, or merely adapting an existing application to use different presentation technology. These programs allow the user to pay a monthly or yearly fee for use of a software application without having to install it on a local hard drive. A company which follows this strategy is known as an application service provider, and ASPs are currently receiving much attention in the software industry. Security breaches on these kinds of applications are a major concern because it can involve both enterprise information and private customer data. Protecting these assets is an important part of any web application, and there are some key operational areas that must be included in the development process. This includes processes for authentication, authorization, asset handling, input, and logging and auditing. Building security into the applications from the beginning can be more effective and less disruptive in the long run. In cloud computing model, web applications are software as a service. There are business applications provided as SaaS for enterprises for fixed or usage-dependent fee. Other web applications are offered free of charge, often generating income from advertisements shown in web application interface. Many businesses are enabled by open-source web applications such as e-commerce software that facilitates easily creating an online retail store. Most businesses today do not need to buy data center hardware such as servers because they are affordably rented on a short-term basis from a plethora of hosting companies that provide turnkey implementations of web applications. It is common for hosting providers to also offer packages of hardware and all necessary software to support the business needs of a company. Innovations in all aspects of web applications are providing tremendous economic value by increasing competition by reducing barriers to entry for new companies. Writing web applications. Writing of web applications is often simplified by open-source software such as Django, Drupal, Ruby on Rails or Symfony called web application frameworks. These frameworks facilitate rapid application development by allowing a development team to focus on the parts of their application which are unique to their goals without having to resolve common development issues such as user management. While many of these frameworks are open source, this is by no means a requirement. The use of web application frameworks can often reduce the number of errors in a program, both by making the code simpler, and by allowing one team to concentrate on the framework while another focuses on a specified use case. In applications which are exposed to constant hacking attempts on the Internet, security-related problems can be caused by errors in the program. Frameworks can also promote the use of best practices such as GET after post. In addition, there is potential for the development of applications on Internet operating systems, although currently there are not many viable platforms that fit this model. Applications, examples of browser applications are simple office software, but can also include more advanced applications such as project management, computer-aided design, video editing and point-of-sale. Benefits: web applications do not require any complex rollout procedure to deploy in large organizations. A compatible web browser is all that is needed. Browser applications typically require little or no disk space on the client. They require no upgrade procedure since all new features are implemented on the server and automatically delivered to the users. Web applications integrate easily into other server-side web procedures, such as email and searching. They also provide cross-platform compatibility in most cases because they operate within a web browser window. With the advent of HTML5, programmers can create richly interactive environments natively within browsers. Included in the list of new features are native audio, video and animations, as well as improved error handling. Modern web applications support greater interactivity and greatly improved usability through technologies such as AJAX that efficiently exchange data between the browser and the server. Web applications allow for easier introduction of new user devices because they have built-in browsers. Drawbacks: in practice, web interfaces, compared to thick clients, typically force significant sacrifice to user experience and basic usability. Web applications absolutely require compatible web browsers. If a browser vendor decides not to implement a certain feature, or abandons a particular platform or operating system version, this may affect a huge number of users. Standards compliance is an issue with any non-typical Office document creator, which causes problems when file sharing and collaboration becomes critical. Browser applications rely on application files accessed on remote servers through the Internet. Therefore, when connection is interrupted, the application is no longer usable. However, if it uses HTML5 APIs such as offline web application caching, it can be downloaded and installed locally, for offline use. Google Gears, although no longer in active development, is a good example of a third-party plugin for web browsers that provides additional functionality for creating web applications. Since many web applications are not open source, there is also a loss of flexibility, making users dependent on third-party servers, not allowing customizations on the software and preventing users from running applications offline. However, if licensed, proprietary software can be customized and run on the preferred server of the rights owner. They depend entirely on the availability of the server delivering the application. If a company goes bankrupt and the server is shut down, the users have little recourse. Traditional installed software keeps functioning even after the demise of the company that produced it. Likewise, the company has much greater control over the software and functionality. They can roll out new features whenever they wish, even if the users would like to wait until the bugs have been worked out before upgrading. The option of simply skipping a weak software version is often not available. The company can foist unwanted features on the users or cut costs by reducing bandwidth. Of course, companies will try to keep the goodwill of their customers, but the users of web applications have fewer options in such cases unless a competitor steps in and offers a better product and easy migration. The company can theoretically track anything the users do. This can cause privacy problems. Affiliate advertisers will reject the site citing lack of original or unique content if it is not a traditional site with lots of text, such as a blog or news site, eliminating a large potential revenue stream. According to Jonathan Zittrain, the online applications like Facebook and Google Apps have made the Internet become far more proprietary than early versions of Microsoft Windows. See also, Software as a Service, Web 2.0, Web Engineering, Web Services, Web Sciences, Web Widget, Single-Page Application, AJAX, Web Development Tools, References. External links, HTML5 Draft Recommendation, changes to HTML and related APIs to ease authoring of web-based applications. The Other Road Ahead, an article arguing that the future lies on the server, not rich interfaces on the client. Web Applications at DMOZ, Web Applications Working Group at the World Wide Web Consortium.